It's now 8 o'clock, Monday, the 22nd of September. Just want to welcome you to the Mathematics Didactics CLC tutorial. And it's just nice to know that there are people out there. I see at least 2 people, 3 people at Salt River. Lee and Andre. Hello. And I think Shireen should also be there. She's probably hiding around. I can't see her, but that's not too serious. But hello, everybody. Thank you. Thank you, Andre. And I look forward to our interaction tonight. And please feel free to use the group chat for any further questions you want to ask as we go along. Right. Yeah, let's just go through and let me show you something of what we're going to be doing this evening. First one is just to start off with 2 icebreakers, and then I'm going to give you feedback on assignments 2 and assignment 3. We're going to show you a PowerPoint presentation about measurement, and then information about assignment 4, and we're going to end off with conclusions and that. All right. So these are some of the things which I'm planning on doing tonight. Please feel free to contact me or speak to me through group chat as we go along. And if I'm speaking too fast or if I'm going too fast, then we'll just take it from that side as well. Right, let's get started. The first point I want to make here is with the icebreaker. Oops, sorry. This is just one icebreaker. You might often wonder why, do we ever learn anything with online learning? Well, I read a recent article from the Massachusetts Institute of Technology in the United States that no matter what, you will learn from online learning. Their research shows that online students in a physics course had similar scores to contact students. Now, the contact students, you must remember, had access to more resources. They had access to the teachers more often than what the online students had. But still, there was no relatively great difference between their scores. And they talk here about the MOOC, Massive Open Online Courses. And the point that they made, Mr. Pritchard, who was one of the presenters or one of the researchers as well, he said that if they stuck it out, if they continued with their online studies, they would have learned something. So, people, tonight, you're going to learn something. Icebreaker 2. Which mass is greater? A ton of feathers or a ton of lead? You can talk about it. Just write your answer in the group chat for me. Yeah, the answer's right. They are both the same, right? It would only be the quantity that would differ. You need far more feathers to make up a ton than what you would of lead. It's just the quantity that. Well done, people, well done. Right, let's go on. There's some feedback from your assignments. Assignment 2, which was the examples of number patterns. And this was one assignment that I think it was your one, Andre, that comes out here. This is quite interesting to see how the pattern proceeds. All right, 4 times 2 times 8 times 2 is 16, and so it would go on. Right, and then this one is also, if you divide, then you get the same sort of similar answer coming downwards, right? And then this was another one, growing patterns. this was interesting because here you on this table the number of triangles. So for one triangle you needed 3 matches. To make 2 triangles you just had to add another 2 matches. But then your total of matches was 5. Right? So for 3 matches, 3 triangles, you would add another, right? 2 matches, and then your total would be 7. Right, now I want you to work out what would be your total number of matches when you get to 6 triangles, and how many matches would you have had to add up here to 6 triangles, and what would be the total number of matches used at 6 triangles? You can discuss it amongst yourselves, come up with an answer. If you have an answer, just let me know in the group chat. Total is 13. You've given me an answer of 13 matches for 6 triangles, and you would have to add 10. All right, let's have a look at the answer there. So for 6 triangles, you would have had to add total number of matches. You said was 13. So 2, 4, 6, 8, 10, 13. That's correct. And then you have 30 number of matches used, right? You will add up 10 more matches in there too. All right, well done, well done. That's your second one right tonight. But I think it just gives you an idea of the patterns that are created by these matches. Right, here's another one. This one I found quite interesting. Look at the work out the number pattern for the year. All right, if you think you have an answer, let me know on group chat. All right, let me try and take you through this. It goes from 7 to 16, and then there's something, and then there's 34. So 7 to 16 would be how many? 9 plus 9. So that would, the answer there, which would, at that point you would want to have 25. right? 34, 43, and then 52, 61, and 70. Well done. All right. Did you notice the sequence? Did you notice the sequence? All right. So we went from 7 to, look at the units. 7, 6, 5, 4, 3, 2, 1, 0. Right. But the tens, the units decreased, but the tens increased. 1, 2, 3, 4, 5, 6, 7. Right, so it's the number plus 9 equals 1 less than the previous number, but in the next 10. So 7 up to 17, but 1 less would be 16, right? Plus 10 is 26, minus 1, 25. Plus 10, 35, minus 1, 34, and so on and so on. Right? Just shows you an interesting pattern, and you can try it with any set of numbers you like. The pattern shows better the higher the number. You can start with a 5 if you want to. You still get the same sequence, but it isn't as pronounced as what it is if you start with a 7 or an 8. It's just interesting to see how we go about these things as well. Right, so that's just something on number patterns. Let's go to your assignment 3. Feedback on shapes and spaces. This first one was an interesting definition of a right angle. Is an angle that bisects a straight line angle formed by 2 halves. Right? And here you can see at this diagram over here, there's a straight line angle, 0 to 180, and then the right angle will bisect that straight line angle. Right? That's 90 degrees to it. This diagram is also a very interesting one here because you've got the acute angle, you've got the obtuse angle, and you also have in the red, you have the reflex angle as well. And then you also have the right angle too. And then just also on this one is just the letter A you can use to form an acute angle, and the letter V would be used to form a reflex angle as well. There's some interesting things there about the various angles. Right, and then this question here. Now I'm just going back to group chat. I just want to show you. Yeah, all right. So the issue is that if you've got a square or a rectangle, right, and you draw a straight line on the diagonals, that diagonal line will always be longer than either of the sides of that angle. Right? The diagonal line is longer than the sides. And that shows that you can always fit the lid or the square into the hole. Now over here I've got the Tupperware, the base of the Tupperware. So you can fit the lid either side down, or you can fit it long ways diagonally down into the container, right, or into the hole. So that is the one reason. That's the mathematical reason, because the diagonal is the longer one, is longer than either of the sides and the squares, whereas in the circular manhole cover, all the diameters will be the same length, and so you won't be able to fit them into the hole, right? Because they're all the same length, and that is very very much what the picture shows you here on the screen. Sorry. What you see here in the square hole, the square manhole cover is able to fit in on the sides, but the circular manhole cover is not able to, and the reason being that the diameters are all the same length. There. Right, interesting. And there were a lot of other interesting information that also came out from various students. One student said that sometimes this is the type of question they ask you when you go for an interview, just to make sure that you can think out of the box. Right? Just bear that in mind. If ever you are asked this question in an interview, I hope that you will be able to give them a good mathematical reason for it being so. Right, let's move on. That brings us to the end of the feedback on the assignments. If there are any other questions you want to ask about the feedback on assignments, you can email me or phone me, and I'm happy to field those as well. Let's go on. Tonight we're going to talk about measurement. And in the CAPS document, measurement is given as the content of the area knowledge. And we speak here about the appropriate units and instruments to measure the measurement. And then it must make sensible estimates and reasonable measurements as well. And then also the content focus for the pupils is to expose them to a variety of measurement activities, get them to learn to use units of measurement, and then select and convert appropriate units of measurement as well. And furthermore, we want to show them that measure different angles, area, perimeter, volume, and capacity, historical development of measurements, and convert measurements using common and decimal fractions. So those are some of the things that we're trying to do when we're teaching measurements to pupils. Just a definition of measurement is finding a number that shows the size or amount of something. Right? Measurement doesn't just go with the height or the mass. It goes with both of those, right? It goes with the area. It goes about showing how big something is, how small something is, and then it also has reference to some standard measurement, a unit of measurement, a meter, millimeter, a kilogram, a milliliter, something of that nature. Right, and then this document, CAPS document, pages 25 to 29 are very, very important for your assignment 4. Right, you talk here, please make sure that you read those pages, 25 to 29. And then also you can look under the resources for the CAPS document. You go and look under the IP Maths, eng.pdf, and that's where you'll find the CAPS document under resources. CAPS document is available on the website as well, WCED website. You just under Google, just type in WCED, Western Cape Education Department, and then you'll be able to access the CAPS document. The CAPS document contains lots of ideas of measuring instruments and what measuring activities that you could use as well. Just one thing I want to throw in here is that if ever you've got to teach time to pupils, it might be a good idea to use paper plates make a clock face out of it with a split pin and two arms, and then you can teach them the time to pupils. And then please just remember that in terms of the CAPS document, sometimes they use the word volume, and at other times they use the word capacity. Now, both of those are the same, right? Volume and capacity are the same, and so you need to tell pupils that as well, so that they get used to using both words and get familiar with them as well. Right, and then, yeah, just some other, I'll tell you, just before I go on to this next point, I'm just going to pause here very briefly, just to make sure that you are okay and that you're up to date. If there's anything you want to ask me now, raise any questions before I go on to the next section. I'm just going to stop for a couple of seconds and give you an opportunity to type in something on group chat if you've got questions. Right, thank you. I see you all good. So if that's the feeling, then I'm good too. So let's go on. I want to tell you about an article entitled The Concept of Measurement. This article is also on your lessons under Unit 4, Measurement. It's an article that's written about measurement and the whole concept of measurement. And one thing that they tell you there is that children measure by comparing. A child will talk about something that is big as opposed to something that is small or smaller. And that's quite an interesting concept for children as well. They measure by comparing. And then what's also important to ensure that when you tell children about measurements, that you also teach the appropriate measurement unit for them, right? This article, Concept of Measurement, tells a story about a girl. Well, the mother had at first, at birth, this mother measured her baby, and the baby was 19 inches long. So what the mother did was that she took a piece of perspex and she measured out 19 inches of perspex. And then the baby's name was Elizabeth. So she said that that length of perspex represented one measurement of Elizabeth. So that was one Elizabeth. And then when Elizabeth eventually got to going to grade 1, when she had to start school, they were very keen to see just how she had developed. And so they took the perspex and they measured Elizabeth again. And she was a little bit more than 2.5 perspex lengths. So then that became known as 2.5 Elizabeths. And so Elizabeth developed. And eventually when Elizabeth was in grade 3, Elizabeth was then 3 Elizabeth units, and so on. So as time went on, Elizabeth slowly started developing her own sense of measurements and her own mathematics. And then she started developing smaller units of Elizabeth. For instance, you don't talk about a half a Elizabeth, right? What would half a Elizabeth be? Or what would 1/3 of an Elizabeth be? Or a 2/3 of Elizabeth? I'm going to suggest to you that maybe if you take the word Elizabeth, 9 letters, maybe 1/3 would be the ELI, and then if you're talking about 2/3, it would go up to the B, right? That's just one way of making it. Anyway, so I'm going to leave the story there, but it has an interesting follow-through then I'm urging you to go and read the article, A Concept of Measurement, and then you will see what happens when Elizabeth eventually gets into high school, and then the high school teacher instructs the class to go and do something. I'm going to leave it there for you to follow up on that story as well. But it just shows that we have different units of measurements as well. All right? So, in the room that you're sitting in now, I want you to state the length or the width of that room using a non-standard unit of measurement. I don't want to know how long or wide the room is in terms of meters. Use some other method, some other unit of measurement. And you can write your answer in group chat. Yes, well done. I would have also taken tables, perhaps, and measured the width of the room or the length of the room using the tables. That was a good non-standard unit of measurement. All right. What do you do for the length of a motor car? Now I know that motor cars, you have different sizes of motor cars, but let's just take a normal motor car. What would you use as a non-standard unit of measurement for a motor car? Wheel spanner lengths, all right? Would be a lot of wheel spanner lengths. I would have perhaps taken the height of a man, of a person, being about 1,8 meters. So I would have said that a motor car length of a motor car would be about 3 or 4 persons lying down on the ground, right? But I think we're getting the idea now. Right, now, listen, watch this one. What unit would you use to measure the length of a swimming pool? Yeah, length of a swimming pool. You could also use people length. What about using the number of strokes that it takes you to swim the length of a pool? Right, so you could say it's 50 arm pools of crawl stroke or backstroke or something of that nature. Right? Another example, What unit would you use to measure the capacity of a swimming pool? Now be careful with this one, because now we're talking about something that is different. The number of baths full of water, yeah, you could use that as well. I think this one's also important for pupils, because you've got to remember earlier I mentioned to you that you must always use a unit of measurement that the pupil is familiar with. Now, to tell the pupil that it takes so many 25-liter barrels or drums of water, it's not something that they are familiar with, right? But they'll be far more familiar with so many liters of milk or a liter jug of water, something of that nature. So make sure that you use units that are that pupils are familiar with. And I think this next example is a very, very good one that pupils are familiar with. All right? Children measure time in sleeps. You know, Daddy's coming back from his business trip in 3 sleeps time, or whatever. You know, in the holidays are in 2 sleeps time. That's also something that pupils are very interested in as well. Right, so these are just some of the concepts that this article, concept of measurement, raises. It's quite a thought-provoking article. I suggest you take time out and that you read it as well. Right, let's move on. There's some examples of instruments of measurement: a clock, calipers, right? Some other measuring instruments as well, used for different heights or lengths or whatever. Right, I wish to now just speak about the assignment 4. This assignment is on your on Funda. It's on the lessons. You can get it there under the measurement unit, unit 4. The e-guide is under resources as well. So, and I've just taken a small section of this assignment to highlight it. So what do you have to do for assignment 4? Well, first of all, it deals with measurements, right? You have to design different activities that you can use to teach measurement. You need to design 2 activities for any 5 of the topics of measurement, and there are 6 topics listed there: length, mass, volume or capacity, time, temperature, and surface area. Those 6, of those 6, you only choose 5, and then you submit 2 activities for each topic. That means you will have 10 activities altogether. Make sure you have memoranda for each activity. Activities need to be of a practical nature. Pupils must be able to do them at school, and they can be for any grade. So you might want to do length and mass for grade 4, volume and time for grade 5, and temperature for grade 6, right? Or you can do all 10 activities for a particular grade, grade 6. But please make sure that you include a memorandum for each activity. The rubric for this activity is included in the e-guide. The due date is the 13th of October. So you do have time you've got about a month to go. Please, students, I'm expecting you to do your own work. on this. Don't just go onto the internet and copy other worksheets that are there and then submit them as your own. Remember that you do sign an honor pledge, which states there that you know that you acknowledge that plagiarism is not the right way to do things. So please just make sure that you bear that out when you submit this assignment as well. Right, so let's just make sure that we understand this. It's 2 activities of any 5 of the of any 5 of those topics, and there must be 10 activities in all that you need to submit. Right, and then just finally, I just want to bring it to a close and just say that our next CLC tutorial will be on Monday the 6th at 8 o'clock. And your assignment due date is due on the 13th of October. Don't wait until the end. I'm going to just leave the group chat open for a while in case there are any questions you want to ask me before I close off. Right, if there are no questions, then I'll just close off with this little scene here. I'll just give myself a hat, and I'm going to give myself a drum roll, and I applaud the student. Thank you for being part of the tutorial. All right, and to all of you, I say good night and thank you very much. Bye.